students, good day to every one of you. I want to discuss fractions today, and we're going to consider all operations that surround fraction, like additions, subtractions, multiplication, divisions, converting from one form of fraction to the other. There are two techniques that we can use to add or subtract two fractions. Let me just quickly go to the first techniques. Let's say we have 7 over 5. We are asked to add 7 over 5 with 1 over 4. Now, by the time we have this, we can either use the direct method. I call it the direct method, and the direct method is by multiplying 5 by 4. By multiplying by 4, 5 by 5 by 4, we have 20. That is a method. And thereafter, we then do the crossing. Then we cross 7 with 4. That's the right crossing first. That is 28. That will give us 28. And we know we have the addition sign there, plus. Then we do the second crossing. And that will be the left crossing. Then we have that to be 5 by 1, which gives us 5. And by the time we add the two together, we have this to be 33 over 20. 33 over 20. Now that is exactly the first method. Let us try another one that has to do with what do you call it? Subtraction. Peradventure, let's say we have 3 over 4, and we're asked to add it to, subtract. We're going to subtract 2 over 7 from 3 over 4. We're going to also do the crossing, as I said. We do the crossing. The crossing is, you get the two denominators, will multiply them together. That will give us 28, 7 by 4. Then after that, we now do the right crossing first, just as if you are writing a multiplication sign. That will be 7 by 3. That will give us 21. Then thereafter we do the left crossing. That will be 4 by, don't forget that it's a negative sign. 4 by 2, that will give us 8. And 21 minus 8 give us 13 over 28 as our answer. That's the technique 1. Now in the technique 2, which is most common, and we can use it for many operations. In technique 2, we have, let's say we have 3 over 4, and we are asked to subtract 2 over 7. I'm actually using the last example for that, 2 over 7. Now, in these techniques, what we're going to do here is we're going to look at the denominator, the two denominators. We have two denominators. We have 4 and we have 7. Now, if you look at 4 from the left, you can see that 4 is the denominator. We then multiply the right by 4. In the left, we have 4. We now go to the right and we multiply it by 4. We multiply both the denominator and the numerator by 4. Now we come to the left, it has 7. This left has 7. We now come to the right and multiply both the denominator and the numerator by 7 as well, because that is what is missing. Because there are two denominators, that is 4 and 7. We can see in this one is lacking 7. That's why I'm going to multiply. It's as if you are multiplied by 1. It does not change anything. And this one is lacking 4. That's why I'm going to, it's lacking 7. That's why 4 rather. That's why you are going to multiply by 4 or 2. Now, by the time you do the multiplication, we are going to get just like the same thing like the one we did, like 7 by 3. We have 21 over 28. That is from 7 by 4 minus, we have this one to be 2 by 4. That will be 8 over 24. If you check our last example, that's exactly what we get. So now, once we have the same denominator as a fraction, don't mind me, this should be 28 as well. That should be 28. This will be 28. I'm sorry for that. So this is 37 by 4, 28. Once the two denominators are the same, you can see that the two denominators are the same. Thereafter, we can just carry the operations that we have. Once it's addition or subtraction, we can just do the addition or subtraction of the numerator. So 21 minus 8, that will give us 13, and that will be 13 over 28 altogether. So that is exactly what the second method is actually doing. Let me see if we let us look at the condition whereby we have 3 fractions. Let us have another example. If we have 3 fractions to perform an operation, let's say we have 1 over 3 plus 2 over 5, 2 over 5, that is 2/5 minus 3/4. But eventually, let's say this is what we are being given. Don't forget, the first technique that I said will not be useful here in this example because it might be confusing. But the second technique that I say will be very, very helpful. Now, we will look at what we have. The denominators that we have here are 3. Look at them. Well, how many we have denominator? We have 3. We have 5. And we have 4. Those are the 3 denominators. 3, 5, and 4. Now, if you look at the denominator together, we will see that in the first denominator, that is 3, that one is lacking. Okay, let me rewrite this expression here so that we can get it very well. Plus 2 over 5 plus 3 over 4. Now, you can see that the first expression, out of the 3 denominators, there are 3 denominators here, which is 3, 5, and 4. The first denomination there, denominator of 3 here, is lacking 5 and 4. 5 and 4 are missing. Out of these 3 denominators, the 3, 5, and 7, now 5 and 4 rather, this one is not having 5 and 4. This one is not having 5 and 3 and 4. And this one is not having 3 and 5. So we now come here to the first one here. Since it's lacking 5 and 4, 5 and 4, it's lacking 5 and 4. So you now multiply both by 5 and by 4. Multiply both denominator. Okay, it's lacking 5 and 4. So 5, 5, 4, 4. Or you say multiply both by 20 over 20. That is the multiplication of 5 and 4. Now, because this one is also lacking, because this one is lacking 3 and 4, then you go and multiply this one by 3. You go and multiply this one by 3, 3, and 4, 4. Now, because this one is also lacking, excuse me, because this one is also lacking, what do we call it? It's lacking 5 and 3. Then you multiply both by 5, 5, and 3, 3. So if you do the multiplication all together, what do we have? We have something like 5 by, that is 20 on top here. Let's look at the top here. 4 by 6, that will be 24 on top of the second. The third one is 45. Now the goal of this, if you look at the goal of this, is for us to have a uniform denominator. That's why we are multiplying all this kind of gimmicks, to have a uniform denominator. And when you see that the denominator here will be 60, this will be 60. 4 by 5 by 3, that is for this one, that will be 60 as well. 3 by 4 by 5, that will be 60 as well. And don't forget, we have addition here. Sorry, we have subtraction here. Sorry, the sign here is subtraction. Just subtraction there from the expression. So by the time we have this all together, we can see that every fraction have the same denominator, which is what we call 60. So then this one can be 20. Since they have the same denominator all through, then we can perform the operation that we have on top. So this is 20 plus 24 minus 45. That will be, this will be 44 minus 45. So this actually will be 20 plus 24 minus 45, everything over 60. And this one automatically gives us minus 1 over 60 as our answer. I hope that is very clear. Let's try if we can have another example. Let's try another example. Another example is that when we have 3, let's say we have 3 over sorry, excuse me, 2 over 3, that is 2/3. So we have 2 over 3, and we are asked to add it to 1 over 2, that is 1/2, and we minus 3 over 4, that is 3/4. Then we will look at this one, we look at this together using the technique 2. We can see that the denominator are 3. We have 3, sorry, we have 3, we have 2, and we have 4. Now in the first one here, is actually lacking, what is it lacking? Is lacking 2 and 4. So we multiply this one by 2, 2, and 4, 4. The second one here is actually lacking, what is it lacking? Is lacking 3 and 4. So this is, we multiply it by 3, the first one 3, 3, and we have 4, 4, multiply that. Now the third one is actually lacking 3 and 2. So what do we do with that? We try and multiply it by 3 and 2. So we have it to be 3, 3, 3, and we have 2, 2. Yeah. Then we now do the simplification. Then when we do the simplification, what do we get? Then the division, and this will actually be the, let's look at the denominator first. 24. 4 by 3 by 2. This plus this also 24. I told you that after doing this, the denominator will be the same, 24. Now let us look at that together, the numerator. In the numerator, we have the first one to be 4 by 2 by 2, and that also give us 4 by 4, which is 16. The second one give us 4 by 1 by 3, and that actually give us 4 by 3, which is 12. The third one give us 3 by 3 by 2, that will be 9 by 2, which is 18. So we could see that the denominator are the same all through now. Then we can now take a single denominator, whereby we just do the normal simplification like the normal fraction. Now, if you add, this is what we have, 16 plus 12 plus 18. That will be 28 minus 10. Sorry, minus 18. That will be 10. So this actually will be 10 over 24. And this can be simplified further. If you divide both the denominator and the numerator by 2, we have this one divided by 2, this one divided by 2, then we have the answer to be 5 over 12. 5 over 12. That is the answer. So that's about that. Let's also have another one. Let's try another one. Now, let's say we have a variable 5 over x, and we have to add it to 2 over 3. I want to tell you this is not just as simple, because we have a variable x here. Now, if you look at the denominator, we have both 3 and x, and the first method can be very useful here as well. That is where you do the crossing. Let us try the first method, crossing. By the time you cross this one, you have it to be 3x, and then you do the second crossing, that is the right crossing first. The right crossing, that will be 15 plus, and when we do the left crossing, that's the left crossing, that will be 2x, and then we have this one to be 15 plus 2x, just like that, because we cannot further simplify it. So that is the answer. And we can try this. That is quiz one. Let's try this quiz one ourselves. Try and pause it and try it. The quiz one. Then with first one, you have 7. You are going to simplify 7 over x minus 2 over y. And the second one here is for you to simplify 2 over 3 minus 1 over 4 plus, let's look at 3 over 5. That's quiz one. Please, I want you to just try this and I get the feedback from you. Now, I want to also move forward to whenever we have a denominator that we may not need to multiply both. For example, let's look at this. when we have a denominator in which we only treat one denominator and we leave the other. Let's look at this expression 4x plus 1 over x squared. Look at this expression. Now, if you multiply the first fraction by x, we are going to have a common denominator. Don't forget that the goal is just for us to have a common denominator. So once we multiply the first fraction by x, it gives us a common denominator. So then, what do? We just say we multiply this one by x, and then we have 3x into x squared plus 4x plus 1 into x squared. You can say that we already get a common denominator here. So there's no need of, so then we do the normal simplification. Then we have x squared 3x plus 4x plus 1, since they have it. So this is a like times. They both have the same common variable. So this is 7x plus 1 over x squared. We could no longer simplify further as regards this. This is the last expression that can no longer be simplified further. There, let's talk about the multiplication of two fractions. When we want to multiply two fractions, what do? When we are multiplying two fractions, for instance, 4 over 5, we have to multiply by 5 over 7. We all are comfortable with this. What to do is we just multiply across. And when we multiply across, what do we get? We multiply across, this across, and this across. What do we get here? We get to be 20 over 21. That is across. And that's how we multiply two fractions. Now, if we have two fractions separated by equals to, we can't just multiply two, just like the way we have it. For instance, let's say we have 3 over x, and we have equals to separating them, equality sign separating them, 5 over 9. We can't multiply further. What we do here is the cross multiplication. We do the cross multiplication. So when we do the cross multiplication, what do we have? We have this crossing, and that crossing gives us what? That crossing gives us equals to, we have 9 by 3, what is 20? That is 27. And the second crossing, that will be 5 by x, which is 5x. So when you divide both sides by 5, you get our x to be 27 over 5. And that can no longer be simplified further unless you want to convert it to a mixed fraction. Thereafter, if you want to divide one particular fraction from the other, if you want to divide two fractions, we have the method we call keep, change, flip. Keep, change, flip. And what is keep, change, flip? Keep, change, flip is that you keep the first fraction, you change the division to multiplication, and then flip the other fraction. For instance, let's say we have 15 over 40 divided by 35 over 56. Now this is the two fractions that you want to divide. I'm talking about division of fraction now. Now I said key, change, flip. Key, change, flip is the method we use. That's what we call all these cross multiply, or the key, change, flip is that you keep the first fraction, that is 15 over 40. We keep the first fraction. By the time we keep the first fraction, we change the division sign here to multiplication sign. We now flip. Flipping means you make the denominator to become the numerator and the numerator to become the denominator, and that gives us 56 over 35. By the time you do the kitten flip there, what do we do here? You simplify. How do you simplify? You can do the crossing. Most of you do the crossing, but I can simplify my own as this 5 by 3 over 8 by 5 multiply by 8 by 7, that is 56, and this is 7 by 5, so that I can say, I can cut the 8, I can cut the 7, I can cut this 5. So I have the answer, let with 3 over 5. We have some other method that you can use. You can just do the normal cutting that you are used to, but that's how to divide two fractions by simple flipping. Now we want to also try another one. I want to try another one of the flipping. That's when I have 8, look at this, 8 divided by 3 over 4. The 8 divided by 3 over 4, we can do the flipping. That is the key change flipping. That is to keep the first fraction, change the division sign to multiplication sign, and flip the second fraction. And now what do we have here? Then we have, don't forget that 8 is actually 8 over 1. So we keep that, we change division to multiplication sign, and we do the inversion. That will be 4 over 5. Sorry, 4 over 3. Now, by the time we have that, we have this one to be 32 over 3. I do not need to try to do the simplification or break it down, since there is no point, there's no value that will cut each other. So I don't need to break down the fractions, since nothing can be cancelled, just like the previous example that I showed you. Now I want to give you another quiz. Now I call it quiz 2. Quiz 2. The quiz 2. Quiz 2. In the quiz 2, following the same method, I want you to simplify 28 over 24 divided by 35 over 32. That is 1. That is 1. The second, I want you to simplify 5 over 7 divided by 6 using that key flipping. The third one there, I want you to simplify 5 over 3 over 7 over 6. 7 over 6. That's the 3 questions I want you to work on, which is the quiz 2 in this class. Now I want to move to a complex situation. Let's have a complex situation, a complex problem. So we have a complex problem, just like when we are asked to simplify 4 plus, look at this, 2 over 3 over 5 minus 1 over 3. Look at this. You can see this is fraction, but in a situation like this, we multiply both the denominator and the denominator by the common denominator. We can see that there is a common denominator. The common denominator we have here is 3 and 3. So you multiply both by 3, so that we have multiplied this by 3, or everything here by 3. I'm talking about both 5 and this one and this by 3. Now by the time we multiply this one by 3, we get 12. By the time we multiply 2 over 3, that is 2 over 3 by 3 here, we 3 cancel 3, then we have 2, then we have 12 plus 2 here, over, now 5, this 5 by 3, then we have 15 plus, sorry, that's not actually plus, that's a negative sign. We have minus 1 over 3 by 3, 1 over 3 by 3, that cancel, we have 1. Actually we have 1. So this actually gives us 14 over 14 equals to 1. Okay, that's equals to 1. I think we understand that. Yeah. Now when we have another situation in which the denominator are not the same, when the denomination are not the same, we have, let's look at a more complex situation. 7 over we have 7, we have 7 plus 3 over 4, everything over 9 minus 4/5, 4 over 5. Now let's look at this. Since the denominator are not the same, what we do is to multiply both the top and the bottom, which is the denominator and the numerator, by 4 and 5. You can see there are 2 denominator there, which is 4 and 5. 4 and 5. So multiply both by 4 and 5. So that means there will be 4. That is, there will be 4 and there will be 5. We multiply this one by 4. That will be, it's just as if we are multiplying both top and the bottom by 20. So that will be 7 by 20. Will actually give us 1. 7 by 20. 7 by 2 is 14. That will be 1. 7 by 20 will be 140 plus 3 over 4 by 20. This 3 over 4 by 20. That actually gives us 3 over 4 by 20. So 4 here 1, 4 here 5. So 5 by 3, that will give us 15 over 9 by 20. 2 by 9 is 18. That is 9 by 20 will be 180 minus 4 over 5 by 20. That will be 4 over 5 by 20 will actually give us 16, because 4 by 4 we have 5 cancel 5 in 4 times. 5 cancels 20 in 4 times, so 4 by 4 16. So then we have this one to be 155 over 164. 155, and this cannot be further simplified. This cannot be further simplified. That's good. Now let me also give you another quiz there. That is quiz 3. I call it quiz 3. The quiz 3 says that you should try and, number 1, evaluate or simplify 8 minus 5 over 3. 5 over 3. This 5 over 3 over 4 plus 1 over 4. Now using the same method like what I did, you're going to use this one. Now the second one is 9 plus 1 over 3 into 2 plus 1 over 4 plus 1 over 5. Sorry, plus 2 over 5. Plus 2 over 5. That's a quiz, the third quiz. Okay, let's look at the fraction. How do we convert? You know there are 2 types of fraction. Though some will say 3. There is a proper fraction. Proper fraction is when the denominator is is greater than the denominator. That's when we have a fraction in such a way that we have, let's say we have a over b. If a is less than b, then it's a proper fraction. But if a is greater than b, it's an improper fraction. That is, the top is more of higher value than the bottom. So that brings us improper fraction. And whenever we have improper fraction, we might need to convert it to what we call mixed fraction. So then I will now talk about how do we convert improper fraction to a mixed fraction. A typical example is when we have a case like 23 over 5. This is an improper fraction. You can see the top is higher than the bottom. So by the time we have this, we talk about how many times does 5 goes in 23, and that will be actually 4. And what's the remainder? That is from 23 minus 5. That will be what? That will be 3, and that's over 5. Very direct. Very direct. Then we can also have 14 over 9. We say how many times does 9 goes in 14? That's it. Then that will be 9 14. That will be 1. And what's the remainder? That makes it up. That will be 5 over, what is it? We always still keep the denominator. That will be 9. 28 over 6 actually gives us 4, because 6 goes in 28 in 4 times, and the remainder is 4. And what's the denominator is still the same, 4 over 3. And this one can be simplified to 4/2 over 3. 4/2 over 3. There, another method or another technique is to look at the multiples. You look at the multiples. For instance, look at the case of 17. The case of 17 over 5. That's another method of converting from mixed to, improper fraction to mixed. Now, you see how many multiples of 5, or let's say the highest multiple of 5 before 17. You can see we have 5, 10, 15, 20. So 15 is the highest multiple, and that will be the third one. So we now say this is 3. That's the third one. Before then we can simplify then as 15. We then say this is 15 over 5 plus, it's not remaining 2 over 5. 15 over 5 is actually 3 plus 2 over 5, and this becomes 3 whole number 2 over 5. 3 whole number 2 over 5. Then The last one I want to talk about here, that is in the case we have 29 over 7. How many multiples, or what's the highest multiple of 7 before 29? That will be 28. We have 7, 14, 21, and 28. So that will be 28 over 7, remainder 1. So 1 over 7. So this actually gives us 4. 4 plus 1 over 7. So this actually 4 number 1 over 7. Now, how do you convert from mixed to improper fraction then? Mixed to improper fraction, shortly. From mixed to improper fraction, we have mixed written like, let's say we have 3 whole number 2 over 3. Now, what do we have to do here is that we say we keep the denominator first, that is 3. We now say 3 by 3 by 3. The 3 by 3 is actually what? 9 plus what we have left here, 2. So this actually gives us 11 over 3. That is conversion from the mixed to improper. Look at the case of 5 whole number 1 over 4. Now we keep the denominator first. By the time we keep the denominator first, we have this to be 5 by 4, that is 20, plus what we have left 1, and this actually gives us 21 over 4. I want to believe we're all used to this. So add the two mixed fractions together. That is what we want to do. How do we ask when we have two mixed fractions together? There are two methods. The first one is that you can firstly convert to improper fractions, then you do the addition, or you can add the integers and then add the fractions separately. So adding of two mixed fractions, let's say we have 3 whole number 1 over 4 plus 5 whole number 2 over 3. Now this is the first method. You can convert both to mixed fraction, to improper fraction. So when you convert both to improper fraction, we have this one to be 13 over 4 plus 17 over 3. And then we now do the crossing. We can do the crossing here. The first one is to do the crossing of the denominator. So we have 12. Then we write cross first. That is, we have the 13 by 3. That will be 39. That is the first crossing. I told you the right crossing. You do the right towards the right. Then towards the left for the second one, that will be 17 by 4, and that will give us 68. So by the time we do that one, that will give us 107 over 12. And that is actually an improper fraction. And how do we take it to the mixed fraction then? And if you take this one to the mixed fraction, how many 12 goes in 107? That's actually 96. So we can say this is 96 over 12 plus remainder is 11 over 12. So this actually 90 over 12 is 8. So this is 8 whole number 11 over 12. With that, you have done the conversion. And the second method is you can first add the integers together. Then we do let me have it. We do the addition or the subtraction or whatever you have to perform. Now the main whole number together here is actually 8. You add the 8 there. Wow, you add the 8 there. Excuse me. Yes, we have the 8. Then we now do the normal addition for the two other proper fractions. So this actually we can do the crossing, the normal crossing, the technique 1. So this is 8. This is 12. Now the right crossing first, that is 8. Plus the left crossing there, that is 3. So this is 11 over 12. That's our second method that we can use to do this. Now I'll give you another quiz. I think that should be quiz 4. That will be quiz 4. The quiz 4 says that you simplify 3 over 4 plus 3, 1 over 5, that's 1. 2, you simplify 5, 2 over 7, minus 3, 3 over 4, that is the second one. that you are asked to 5 over 7, 3 over 4. Okay, that's the second one that we want to do. Now, to multiply two mixed fractions together, what do we do? That's the next one. Multiply two mixed fractions together. We have first you convert to improper fraction. For instance, let's say we have 7 whole number 1 over 4. Multiply, you have to multiply it by 3 whole number 2 over 5. What you do here is convert it to improper fraction. What do? We have this one to be 29. Am I right? Yes, 29 over 4. By this is 17 over 5. So do the normal crossing. And when you're multiplying two fractions, that is 493. That is 17 by 29 over 20. That's about that. And to divide two mixed fractions, when you have two mixed fractions, to divide is just the normal way. Now let us have a scenario whereby we have 5 whole number 2 over 7 divided by 3 1 over 4. This is actually 5 plus 2 over 7 over 3 plus 1 over 4. So what do? There is no common fraction there. What do? You multiply both denominator and denominator by 7 and 4. This also by 7 and 4. Because 7 and 4 are the denominator that we have that is not common. So that will be 7, that is 28 by 5, that will be 140, plus 2 over 7 by 28, that will go on to give us 8, and 3 by 28, that will go on to give us 84, 1 over 4 by 20, that will give us 7, and the answer becomes 148 over 91. That is 148 over 91. That is how to divide two mixed fractions. Thereafter, I want to talk about the conversion of fractions to decimal. Simply, how do we convert fractions to decimal? Now, let's say we have 3 over 4. For instance, the 3 over 4, for instance, when you want to convert, the method we use is long division. You do the long division, and what do we do it? That is, we have 4 here, and we have 3 here. Now, by the time we do it, for 4 in 3, nothing. That is, 4 cannot go easily in 3. So we put the decimal point there, dots. Now, we then say, we put dot here, 0. 4 in 30, that gives us 7. That is 7. 4 by 7, that will be 4 by 0.7, that will give us 2.8. That's before, that's 28 actually. Then we have this one to be 0.20. That is 0.20. Then by the time I put 0 here, I drop that 0. That's how. So this is 4 in 20. That actually give us 5. So we have this one 4 by 5. That one give us 0.20 back, and we have 0 here. So 3 over 4 is actually 0.75. It's actually 0.75. Now the second one, let us try another one. Let's say we have 4 whole number 2 over 5 into decimal. We want to convert this one to decimal. So we have 4 already. So we are going to convert 2 over 5 to decimal. That is by long division. So what do? We have 5. We have 4. And there, if we add that, we have 5 in 4. That will be 0. 5 in now in 40. That will be 8. Are we together with that? Sorry, 5 in 20, I think it's 2 over 5. So, sorry for that. It's 2 over 5. So, that's the 5 and 2, not 4. So, 2.0, don't mind me. So, this is 5 in 2, down points. Then, we have that. 5 in 20, that will be 4. So, 5 by 4, that will be 20. So, thereafter, we have 0, 0 here. So, that means this actually gives us 4, because we already have 4 plus whatever we have here, which is 0.4. So this is 4.4. Now, without pressing calculator, I wanted to also try some other ones. As is quiz 5. That will be quiz 5. In the quiz 5, I want you to convert 3 whole number 7 over 8, 3 whole number 7 over 8 into decimal. Using the normal method how you do it. Now the next one I want to talk about is the conversion of fraction to percentage. I do not need to waste time here. When you are converting fraction to percentage, what you do is just you shift by 2 units to the right. For instance, if you have 1.25 to percentage, this is a decimal. This is decimal, because if you want to convert a fraction to this to percentage, the first thing is you convert that fraction to decimal, and from that is decimal to percentage. And I have just taught you how to convert a fraction to decimal. So what we do is that you shift the 0 by 2, and this will actually give us 125. So if you have 0.68 shifted by 2, that will be 68. And I'm talking about percentage now. So excuse me, if you have 0.031, you shift it by 2, that will be 3.1. That will be 3.1%. And when we have 0.0015 shifted by 2, that means we have 0.15%. So when you're converting from decimal, from fraction to percentage, convert that fraction to decimal. From decimal, shift the movement to the right, move 2 units to the right, and that will convert that particular fraction or decimal to percentage. Conversion from decimal to fraction, back to fraction. How do you, when you are given decimal, how do you convert it back to the fraction? Now, what you have, let's say we have 0.2. Now we can see 0.2 here is we have one digit after the decimal. So what we do is that we just multiply this over 1, multiply it both by 10 over 10. Then this is by 10, you shift this is 2 over 10, and that is 1 over 5. So if we have 0.3 for instance, let me try 2 digits. Let's say 0.24. Now there are 2 digits after decimal here, so that means I'm going to make use of 0 by 100. Since there are 2 digits after the decimal, we are going to multiply both denominator and numerator by 100. So that will be 24 over 100. And you can also break that one down to be 12 over 50, 6 over 25. 6 over 25. That's when you use 4. When you divide both sides by 4. That's about that. And if there are 3 digits now, okay, there are 3 digits now. Do you expect to shift by 3? You multiply by 1000 over 1000. That is 2 1 over 1000. Just by 1000. Now, I want to lastly talk about repeated fraction here. When we have a repeated fraction, what do we do? What do we call a repeated fraction? For instance, a repeated fraction is when we have 0.2 bar. And this actually means 0.2222 like that. And what this actually means is 2 over 9. That's actually what it means. When we have 0.4 bar, it actually means 4 over 9. That's 0.4444444 equaling. With sometimes we call it equaling or repeated fraction. So if you have 0.3 bar, it actually means 0.33333, and that will be 3 over 9, which is 1 over 3. So in repeated fraction, if you have, like, let's look at the case whereby we have 2 digits, 0.23 bar. When we have 2 digits, this actually will be 23 over 99. It becomes 2 digits now, it becomes 99 instead of 9 for single digits. If you have 0.36 bar, 0.36 bar will actually be 36 over 99 instead of 100. Once there's a bar, it should be short of 1. Are we together? Yeah. So if we now have to have, let's say we have 3 digits now, how do we do it? 3 digits in a repeated fraction. Let's say we have 0.126 bar. Now this is actually will be 126 over 999. And 126 over 999 can also be further simplified to 42 over 333. And that will be 14 over 111 if you divide through by 3 for repeated fraction. So you can also try this as well for, that is quiz 6. Quiz 6, I want you to work on 0.315 bar as a repeated fraction. Now I want to work on how we deal with something like this. Quiz 6 is that. So let's look at a complex situation whereby we are asked to convert a particular repeated fraction to a repeated decimal, or repeated fraction as well to a fraction, a proper fraction. For instance, let's say we have 0.43, but this actually becomes 0.3. It becomes 0.3 bar. That is 0.33 plus 0.1. If you add these two together, it gives us this back. If you add these two together, it gives us this back. So this actually 0.3 bar is 3 over 9 plus, don't forget that 0.1 is 1 over 10. So this actually becomes 1, when by the time I do the SCM, the normal crossing, sorry, 3 over 9, don't forget that 3 over 9 is 1 over 3 plus 1 over 10. So when I do the normal crossing here, I have my SCM to be 30, and when I do the right crossing first, the right crossing first becomes 10 plus the left crossing, which is 3. So this one becomes 13 over 30. 13 over 13. So I want you to also look at, that is my last quiz for the day, quiz 7. Quiz 7. Quiz 7. I want you to convert this repeated decimal to fraction. First one is 0.6, 0.63, sorry, 6323. That is first one. Convert it to fraction. And the last one is 0.5813 bar. Sorry, this one has a bar. This also has a bar. 0. The 23 has a bar. This 13 has a bar. 0.1313. That is 1232323 that is recording here, and it's 1313 that is recording here. 0.6323 bar. And I want you to convert it to the proper fraction without pressing your calculator. That is the quiz 7. And I hope you have been able to been able to learn new thing as regards of fractions. In our next class, I will be discussing how we follow BODMAS in dealing with fractions. That's operations of fraction, when we have all this addition, multiplication, subtraction, division mixed together in a single experiment, a single question. How do we sort them out? And that is by using BODMAS. We are going to talk about that in our next class. I am very pleased that you must have been able to gain one or two things during this class. Thank you very much for viewing. Thank you very much for your attention. Your tutor has been S.Adebayo of A Plus Model School, Ipetubodo, Osun State. Thank you very much. God bless you.